Okay, so welcome back to example 4 in our videos for finding the zeros of functions. And this booklet that you also were given in class, the Using Technology to Find Zeros and Extrema, okay, that book looks like this. And these instructions on the inside will help you identify the zeros or the roots using the TI-84 or 83 graphing calculator series. So this example, negative 1/4 x to the 4th plus 3 over 2x squared plus 3, that's worked out in here for you. Okay, we're going to go through these steps together in example 4, but I just wanted to point out that these notes are available already printed out for you in a reference in that identifying roots using the graphing calculator page. Okay, so when we look back here again at example 4, in order to walk through this, we're going to need our graphing calculator. So I'm going to pull up my TI-84, but you could be using a TI-83 or a TI-84 plus. Any of those are going to work fine. Okay, first thing we want to do is go to the y equals, and in y1 we're going to type in the equation that we're given. So negative 1/4 x, and then that's getting raised to the 4th power. Okay, that's plus 3 over 2, and then x to the 2nd power, and then the constant is 3 at the end, so plus 3. Okay, now we're going to go up here in the choices here in the middle. At the top is zoom, and then zoom 6 is zoom standard, which gets us a negative 10 by 10 in the x and the y direction. Okay, so we can see that this makes a sort of M shape here, and if you press this button that is see up above where it says trace, it says calculate, and that's blue. If you press this button that says second and then trace, that's going to access the calculate menu, the calc menu right up here. And the second one down in the calc menu is 0, right? So we press 2. Now the calculator is going to ask us 3 questions. Okay, the first question it asks down here in the bottom is, what is the left bound? Okay, that's asking us to find a point to the left of where the 0 is. And if we look at the graph here, there's 1, negative 2, negative 3, and it looks like it's crossing right on the inside of negative 3. So I'm going to type in negative 3 as my left bound and press enter. Okay, now it asks for a right bound, and I'm going to pick a number, an integer, that's to the right of where that 0 occurs on the x-axis, and that looks like negative 2. So somewhere between negative 3 and negative 2. Now, if I've done that right, it's going to put these little arrows here and ask me, is my 0 somewhere in between those arrows, right? And it is. And it asks me if I want to make a guess. Now, if you want to make a guess, negative 2,5 would not be a very good guess, right? Because that's not even on the x-axis. So you could type in something smaller, like maybe negative 2.75, negative 2.8 if you wanted to guess, or you can just press enter and it's going to tell you where it is. So this 0 is at approximately negative 2.753648. Now we want to round that to 4 decimal places. So we're going to take a value and look at the 5th decimal place to round to 4. So 0.7536, that's 4 decimal places. The 5th is a 4. Okay, and because the 5th decimal place is not 5 or greater, we're just going to keep that rounded down to x is approximately negative 2.7536. Okay, because this, to round to 4 decimal places, we look at this place value, which is the 5th decimal place. Okay, and that would be my approximation to 4 decimal places. Now we found that by using an integer left bound of negative 3 and an integer right bound of negative 2. Okay, and that was where that sign change occurred, right, where the y values went from negative to positive. So when I'm looking at my calculator, if I went to the table of ordered pairs and, oh, I gotta go back to my, let's go back to my table set. I have it set to ask, so I'm gonna change that back to auto. There we go. And now I can look at that table of ordered pairs, and as I back up here to -2, -3, right, you can see here from -3, where I have a negative y value, at -2 it becomes a positive y value, and that's that sign change that we just talked about in the last video in example 3. So that interval from -3 to -2, that's my left and right bound that I use to find my approximate zero. Okay, now you're gonna want to repeat these steps to go find the second one. So if I go back to second, calculate, and then number 2 is the 0. Now my left bound needs to be a value that's on the right side of my graph here. So as I count these tick marks, 1, 2, 3, 4, right, it looks like it's on the inside of 3, so somewhere between an integer left bound of 2 and an integer right bound of 3. So in my my calculate menu, for my left bound, I'm going to use +2 and press enter. For my right bound, I'm going to enter +3. Then it asks me to guess, and I press enter. And there's my approximation. So my 0 is approximately 2.7536477. So when I want to round that value to 4 decimal places, I look to the 5th. So there's 1, 2, 3, 4. The 5th is a 4. So my approximation is going to round down to 2.7536, and those would be the 2 decimal approximations for the real zeros in example 4. That brings us to the secret question for this lesson, where you're going to use graphic technology to approximate the real zeros for f of x equals 3 plus 5 over x, and for g of x is equal to the square root of the quantity 2x plus 11. So for these two problems in the secret question, I want you to sketch a picture of the graph, and then tell me what the 0 is to 4 decimal places of accuracy, and then same thing for g of x. Sketch a picture of the graph and show me the decimal places to 4 place values. Okay, when you've got that finished, you're going to upload the answer to that secret question as the last page of your notes in Schoology.